Hi everybody, welcome to Matrix Operations. This is Mrs. Pagan, and in today's goal we're going to be adding and subtracting matrices as well as multiplying these matrices by scalars. Alright, here we go. There's a few things that we want you to know about these matrices, and the first thing is we want you to be able to identify what a matrix looks like, how many rows does it have, how many columns does it have, how do you read it, and so on. So first thing we want to do is look at the matrix A. So in this case, matrix A is what you see right here. We have dimensions on this matrix, and the way we represent the matrices dimensions are through its rows and how many columns it has. Okay, so in this case we have row 1 and row 2, so there's 2 rows and it has 3 columns. Therefore we say it has dimensions of 2 by 3. I'm going to go ahead and write that, 2 by 3. So that's how we read it. Now, dimensions are always written first come rows times the columns. So whatever the row is, how many rows it has by the columns is the way we read the dimensions, just so you know. The entries are the numbers that we see inside of it. So for example, if I were to look at this, the entries are all the numbers, 6, 2, -1, -2, 0, and 5. So I'm going to go ahead and write that. 6 is an entry, 2 is an entry, -1 is an entry, -2 is an entry, 0 is an entry, and 5 is an entry. Alright, great job. So let's kind of go ahead and look at the different types of matrices that we have, just so you know the definitions. They're very simple. For example, in this one we have 1 row, so this is called a row matrix. The second one is a column matrix because it has 1 column. Okay, this one is a 3 by 3, so it is a square matrix. And the last one is all zeros in there, so it's a 0 matrix. So the definitions of these are pretty self-explanatory. If you just look at it, it's basically a description that we're trying to give to the matrix. So once again, 1 row, row matrix, 1 column, column matrix, 3 by 3, so it's a square, so a 4 by 4 would be a square as well. And all the entries are zeros, therefore it's a 0 matrix. Alright, well done. Let's look at the next part. Now, we can have equal matrices. And if they are equal, we know that the dimensions are the same and the entries are the same. The numbers inside of the matrices are the same. So we're going to go ahead and look at the first one. We want to tell whether these two matrices are the same or not. Sometimes they could be written out. First of all, I know that this has a dimension of 2 by 2. And the second one has a dimension of 2 by 2 as well. So they do have the same dimensions. Now we want to know, do they have the same entries at the same locations? Well, I see that they have a 3 right here and a 3 right there. I see that there's a -1 right there and a -1 right there. So we know those match up. Now, 5 halves and 2.5, I want to know, is that the same? So if I use my calculator, 5 divided by 2, is that the same thing as 2.5? And what you'll find out is yes, they are the same. Okay, therefore I'm going to give them the same shape. Now I also want to know, is -1/5 the same as -0.2? And if you use your calculator, you're actually going to see that they are the same number. The -1/5 does equal -0.0. Oh, sorry, let me erase that. See, everyone makes mistakes. 0.2. Alright, so therefore we can say that these are equal matrices. Alright, let's look at the next one. Looking at the dimensions of this next one, you can see that this is a 2 by 2 and the second matrix is a 2 by 2 as well, which is awesome. But I'm looking at 1 and 0 and they're not equal, therefore these are not equal matrices. I don't even have to look at the others because equal means that they have everything the same. And in this case, they already don't. So we don't, waste our time looking for all the other ones that could be the same or could not be the same. Matrices can also be added and subtracted, and the only time that happens is if they have the same dimensions. So we want to make sure that they have the same dimensions, and then we can go ahead and add and or subtract these matrices. Okay, so let's kind of go ahead and look further into this. We can see that there's 1, 2, 3 rows and 1 column in the first matrix. Well, we can also see that the second one is a 3 by 1 matrix as well. Therefore, we can go ahead and add them. Now, the way we add them is we actually take where they are the same. So 0 is in the same location as 1. Therefore, we can go ahead and add those. Now, the matrix that we're going to get is going to be like this. 0 plus 1 is 1. And we put it in the same place that we found it. All right, next spot is going to be 4 and negative 9. Well, what we're going to do is add them. So we have 4 plus negative 9 is negative 5. And then last but not least, we're going to do the same thing with the 3 and the 8. They're the ones that match up. So we're going to go ahead and add them. 3 plus 8 is 11. So that's our final answer. Now we continue this until we get to the next one. So for example, we can see this matrix is a 2 by 2. And so is the second one. So now we know we can subtract them. And we're going to go ahead and do the same thing. We know that 3 minus 2 is going to give us the answer in that space. So we are going to have a 2 by 2 matrix as well. 3 minus 2 is 1. We're going to put it exactly where 3 and 2 are in both matrices. All right, we're going to go ahead and do the same thing. We have 3 minus 0. And we're going to go ahead and subtract. 3 minus 0 is 3, and we're going to put it in the same place. We're going to continue this. We have 9 minus negative 3. Well, now you have to be careful here. I'm going to move that to the side actually. 9 minus negative 3 is the same thing as 9 plus 3. Therefore, it's 12 that we have in that space. You do have to be extra careful with the double negatives. All right, let's look at the last one. We have negative 5 minus, all those colors made it, let's erase it so we don't lose that negative, minus 5. Well, negative 5 minus 5 is going to give us negative 10. And that's our final answer for that problem. All right, let's go ahead to C. In number C, the first matrix is a 1 by 2, and the second one is a 2 by 2. And since the dimensions are not the same, we cannot add the matrices. So that's the one big requirement that we have to follow. And in this case, we can't do it. So that's our answer. All right, let's keep going. I just want to say you guys are doing a great job, so keep going. All right, so we're going to multiply an entry in the matrix by a number outside. So you can see the entries inside the matrix, and there's a number 6 on the outside. It's our scalar. And this is very much like distribution. So what we're going to do is distribute the number on the outside to every number, every entry on the inside, even to the 8 and to the 4. So here's what it looks like. You don't have to have same dimensions because you really can't. So what we do is we just create a matrix, and I create a matrix that's going to give me a 2 by 2 because the matrix here is a 2 by 2. And what we do is 6 times 2 is 12. 6 times negative 3 is negative 18. 6 times 8 is 40. Is it 48? Yeah. 6 times 4 is 24. And that's our final answer. Well done. All right, now let's look at part B. Part B looks a little bit complicated because it's kind of 2 problems in one. So first thing we want to do is, if this was negative 1 times 3 plus 4, let's simplify it. Instead of matrices, let's just put 1 numbers. You would do negative 1 times 3 first before adding 4. because the order of operations does matter. Well, we're going to go ahead and use the order of operations here as well. So we're going to go ahead and distribute the -1 to all the entries first. And when we do that, we get -1 times 4 is -4. -1 times -7 is +7. -1 times 3 is -3. -1 times 3 is -3. -1 times 2 is -2. -1 times -9 is 9. And then we go ahead and add that to the next matrice. I'm just rewriting it. Now I do have to check to see if these are the same matrices, same dimensions, before I can add them. So this matrix has 3 rows and 2 columns, and this one has 3 rows and 2 columns. Therefore I can actually add them. Now what we want to do is just add the things that are like. That was an awful matrix, so I'm going to have to erase that and redo that part. Alright, here we go. -4 plus 3 is going to give us -1. 7 plus 6 is 13. I'm getting the plus because there's a plus sign between them. -3 plus 9 is going to give us 6. -3 plus -8 is going to give us -11. -2 plus 1 is -1. And 9 plus -4 is +5. And that's our final answer for that entire problem. Well done. Alright. Now there's a last type of problems that we want to show you. And these are the type of problems where it says solve the matrice for x and y. And what you'll see is there's usually an x and a y in these problems. So here's the y, you see it, and here's the x. So what we do is we would treat this as if it's a regular problem. So we know that the number 4, is being multiplied to both of these matrices. So what we're going to do is distribute that 4 first. So we're going to take 4 times the first matrix, 8, 0, -1, 2y, plus 4 times the second matrix, 4, 1, -2x, 6. And we're going to set it equal to the final matrix. Now we want to combine all of these before we get too in deep. So I like to distribute the 4's in, and then we'll kind of start seeing what's really important in us trying to find what x and y are. Because some of the information we have is not going to be helpful. We're going to go ahead and distribute the 4 into the first matrix. So 4 times 8 is 32. 4 times 0 is 0. 4 times -1 is -4. 4 times 2y is 8y. And we're going to do the same thing with the second one. 4 times 4 is 16. 4 times 1 is 4. 4 times -2x is -8x. And 4 times 6 is 24. And equals. Nothing happens to the last matrice because it's just kind of on the outside. And then what we want to do is combine and get the equations with the x. Now, here's an x. We're trying to solve for it. So what we want to do is find all the pieces that connect to it. So for example, we got a 0, we got a plus sign, -8x equals -48. So since those are all the ones in the same place, we can actually pull that equation aside. 0 plus -8x equals -48, and solve the equation for x. Notice that everything is gone. Well, 0 plus is nothing. So if we divide by -8, x in this case is going to equal 6. So we solve for x. That was awesome. Now we want to do the same thing for y, so we're going to go to where y is located. So we have a y right here. So we're going to use the plus sign, the 224, the plus sign again, the equal sign, and the 8, because that's where they're all located. And we're going to write our equation. 8y plus 24 equals 8. We're going to solve. Subtract 24 on both sides. 8y equals -16. Divide by 8, and y equals -2. So our answer is x equals 6 and y equals -2. We don't have to write it as a point because these are not intersecting at a location. Alright, well done. Now we're going to go ahead and try this one in class, But what I want you to do is try it on the side, kind of give me half the paper for class. So why don't you go ahead and try right here, and then we'll go ahead and do it again in class to make sure if you did it correctly